Okay guys, what we're going to talk about now is what we call direct proportion. Okay, this is not actually in your book. I always do this as an introduction because it makes the follow-up, which is actually 6.2, much easier if you first understand direct proportion. Okay, so direct proportion is a type of relationship you can have between two variables. All right, you can see here from the graph, from the table that I've made, we've got a table here with x and y values. Okay, now if we look at this table, you can see, hopefully, that each time if we do y divided by x, we will get a little bit of a pattern here. Okay, so if we do 12 divided by 3, we get 4. Okay, if we do 16 divided by 4, we get 4. If we do 20 divided by 5, we get 4. Okay, if we do 24 divided by 6, we get 4. And if we do 28 divided by 7, we get 4. Okay, you can also see that each time we move forward in the table, it's plus 4. Okay, now this is what we call a direct proportion relationship. And the reason we call it a directly proportional relationship is because each time you change the value of x, y goes up by the same proportion. Okay, so let's make a graph of this and see what it looks like. So if we start with, we can make an xy axis like this. Make it a little bigger. Okay, we have x values, just trying to get this in the right spot. Okay, that's not going to happen. There we go. All right, so let's put our x values on the x-axis. So 1, 2, 3, 4, 5. It doesn't really matter. Okay, now on our y-axis we need to go up to approximately 30. Okay, 1. Oh, lovely. Every one of these is worth 3. So we have 6, 12, 18, 24. All right, so if we make a graph of this, we will see what a directly proportional relationship looks like. Now we have an x here and a y here. Remember, always label your axes. So our first point was 3, 12. Our second point is 4, 16. Our third point is 5, 20. The next one is 6, 24. And then 7, 28. If we draw a straight line through these points, you get this beautiful graph. And what you will see if we extend this line is that it goes through the origin. So it goes through 0, 0. And that's one of the features of directly proportional relationships. So if it's direct proportion, we always have a straight line, and it always goes through 0, 0. Okay, now the reason we're doing this is because it's really important that you can do this with the next type of function. Okay, so there's a couple of other steps I want to look at. So we said here that if you do y divided by x, you get a number. Okay, now the general formula for direct proportion, so the general formula is y equals ax. And that's really important, okay? And that's what it means when we say directly proportional. If you say something's directly proportional, straight away we write down y equals ax. It means you've got a constant, which is the a, times your variable x. Now, from this formula, we can work out the A value and then we have our formula. You will always get enough information to work your formula out. So you're always going to get 1 or 2 points. Okay, we can actually just substitute any point in here and we can find out what that A value is. We've already done that, of course, but if you didn't know this already, you just have the table. Let's look at a value in the table. So we're going to look at this section here, 520. So that's what we've been given as one of our points. We're going to substitute that in. Where will I do this? Underneath. So we had 5, 20 was our point. And we know our general formula is y equals ax. Now, in this case, our x is 5 and our y is 20. So we're going to substitute 5 in for x. Okay, and we're going to substitute 20 in for y. So 20 is a times 5, or correctly, 20 equals 5a. If we want to work out what a is, all we need to do here is divide both sides by 5, and we end up with a is equal to 4. Remember, always write your variable on the left. Okay, so we can straight away say here that our formula for this relationship is y equals 4x. Okay, so your general formula is always y equals ax, and all you have to do in order to work out what that formula is substitute one of these in. Okay, and this is for direct proportion. Okay, so with direct proportion, it goes up. If you look at your table, your values go up by the same amount each time in proportion to the x increase. Okay, so you can see here above that our x's always went up by 1 and the y's always went up by 4. So that's why we can say that it is direct proportion. Okay, so we always have that. That gives us a straight line that goes through 0, 0. And our general formula is y equals ax. Basically, this is the same as your standard formula of y equals ax plus b, except b is 0. Okay, so this is direct proportion. You will, if you're doing wisc-r, you will do quite a bit on this next year. So it's really important that you do understand this quite a lot. And in the next lesson, we will do the next type of equation, which will give you a bit more of an understanding of why we've done this extra bit, because it does help you a lot with understanding the next part.